Hello and welcome back. Again, this is Mr. Parsons. So this is a note on how to graph quadratic functions in standard form. So the first thing that we have to remember is the vertex form. So the vertex form is that a x minus h plus k. So where the h and the k is the vertex, and that a affects how steep or how wide the graph is. So, in this example, 3, x minus 5 squared plus 4, the a is 3, the h is 5, and the k is 4, so the vertex is 5, 4. Well, the problem comes is if it's not in vertex form, if it is in the standard form, the ax squared plus bx plus c, there's a different method. So we had previously talked about the coefficients, the a, the b, and the c, and how to identify them. So at first, this example, so you'll notice that the a is 2, the b is 4, and the c is 9. Now, make sure that you do not use the variables. The a, b, and c are just those coefficients or numbers in front of the variables. So in the next one, it's -3, -5, and 1. Then what gets a lot of students is in that third example, that x squared appears to be alone, but it's not alone. There's always this invisible 1 there. So remember, if there isn't something there, if you're just seeing an x or an x squared, it's 1. Let's say one of these terms, let's say this -5 isn't here. Maybe it's just 3x squared plus 1. Well, then the value is just 0. If you don't see a term, then it's 0. But if you see a term with no number, then that's a 1. So how do you graph with standard form? So the first thing you have to do is you have to calculate the vertex. So you're going to have to do a little bit of math here. So first step, you identify the a, b, and c. No variables, okay? Then you use this formula. And this formula actually finds the axis of symmetry. And it's x equals the opposite of b over 2a. Opposite of b, meaning like if I go back here, if b is 4, the opposite is -4. If b is 5, it's +5. The opposite is always the opposite sign. So then I take that, whatever I get for the x, and I substitute it in for each x in the equation, and I solve for the y value, and that's my vertex. So here's example 1. So the first thing I have to do is I have to identify a, b, and c. Now I plug it into that x equals the opposite of b over 2a. So x equals -4. So you'll notice the two negatives, it'll be positive. So you could just plug in a +4, or you could plug in the double negatives, divided by 2 times my a being the 1. So it becomes 4 divided by 2, which is 2. So that is the first part of this. Now I take it, and I take that x, and I plug it in everywhere I see an x. So 2 squared minus 4 times 2 plus 3. 2 squared is 4, minus 8 plus 3. I get my grand total of -1. So then my vertex is 2, -1. Next problem. So you'll notice that my a, b, and c I locate first. When I plug it into the formula, you can plug it in as, remember it's opposite of b, so this is going to be a -6 over 2 times a, which is -1. -6 divided by -2 is that +3. I then plug it in. So the trick with this one is 3 squared is 9, and then the negative happens. If this negative was inside the parentheses, it would be a positive result, but because the negative is out in front, it becomes a -9 there. So -9 plus 18 minus 1, I get y equals 8. Grand total, vertex 3, 8. This next problem, I'm going to pause. You should pause the video right now, and you should try this one. So start by labeling your A, B, and C. Next step, opposite of B over 2A. Get that result, plug it in, and solve for y. When you pause the video, then run through. Be sure to pause it. Okay, here's the answers. There's your vertex. So the key with this is always calculating the vertex first. Then we can graph. Now, the best thing about graphing is that it's symmetric. So remember, there's that line of symmetry right in the middle. So if I choose some points over on one side, they're going to be reflected on the other side. So I use a table for this. So the first 3 steps are the same. Step 4, you're going to put the vertex in the middle of your table. And I'm going to show you how to do that. And then you use corresponding points to fill in those x values. And then you can either use the pattern to quickly fill in the table, that 1, 3, 5 pattern to fill in the table, or you can take those x values and plug them in. I'm going to show you both ways. So in that first example, we've already calculated the vertex. It's 2, -1. What you're going to see is I'm going to put it in the middle of my table. Then, what I mean by corresponding points. So this 2 here is in the middle. So what I do is I choose 2 numbers above 2 and 2 numbers below 2. But you want to count by ones, okay? So you need to just go 1 higher, 1 lower, okay, each time. So 2, 1, or 0, you notice they're just going by ones. And then on the other side, it would be 3 and 4. Now, because A is 1 here, the quick and easy way is if you remember the pattern, these y values are going to go up. So from -1, it's going to go up 1 and then up 3. Up 1, up 3. So all I'm going to do is I'm going to add those numbers and I get those results for my y values. Now, remember that these are symmetric, so they're going to be the same on each side of the vertex, and that's going to save us some time later. So now I can plot those points, and then you can draw in the graph right here, okay? So that's how you would graph that. In my second equation, again, I calculated the vertex is 3, 8. So I'm going to put that right in the middle. So what I'm going to do is I choose those points. Okay. Now, 2 options here, and I'll show you both options. Now, the A is -1, so the pattern's going to change. So usually it goes up 1 and then up 3. Because this is negative, it's going to go down 1 and then down 3. Okay, so I could do that. But if you can never remember the pattern, you can always, just like we calculated the vertex, take the x value and plug it in. You're going to get the same result. So if I do the same thing, I take 2 and I plug it in, I get 7. So that 7 would go here. I got the same thing doing the pattern. Okay? Now, I do not need to do it for 4 because I know this number and this number are going to be exactly the same. And I can repeat it again with 1. So 1 I plug in, I get 4. I get the same result as if I use the pattern or if I plug the number in. Whatever one is easier for you, you should try to complete. Now, I'm going to let you plot these points. This is your graph, okay? And you would just have to draw in that parabola. Try this next problem. Again, remember, start with the vertex in the middle, and then you can either use the pattern or you can plug those points in. Pause the video and try this example and see if you can get the same points that I get. Done pausing? All right. So there's an easy one for this. So if I do this, I'm going to do -2, -3, 0, and then 1. Now, a lot of times students default to doing these when I'm plugging it in, okay? This 0 really helps you out because when I plug in 0, everything here cancels and I'm just left with that. The trick is this C value is always my y-intercept. I can always plot it right there. So you also should have noticed that the pattern is not going to be 1, 3, 5. It's going to be double because there's a 2 for the A. So I hope you added 2 and then added 6. Or when you plugged it in, you got these results. Now, things that will throw you off. How do I plot -3, 15? Well, you kind of just plot the ones that you can, and then you can estimate. But you can kind of get the idea of this is going to be a steep graph here, okay? So hopefully you understand the basics of graphing in standard form. Please, complete the practice and ask questions as you need. Thank you very much.